Dr. Mark Changizi here through Science Moment. Today I'm going to talk about why we see perceptual illusions. I'm going to touch upon that and then point you to an earlier TED Talk where I go into detail about that. In about a week, the book by Dr. Tim Barber and I that we've been working on for 10 years, Expressly Human, Decoding the Language of Emotion, is coming out. It's the grand unifying theories of why we have emotional expressions and de facto what masks cover over, and it also serves as the foundations for why free expression works as well as it does in the way that it works in societies. So go get yourself a copy of Expressly Human. You can get yourself a signed copy if you go to FreeX and go to Emotion with the links with Emotion. You can get sent a signed copy, or you can go to Amazon, Barnes & Noble, so forth, and get yourself a copy. And you can also get it through an Audible book with me as your narrator. So today I want to mention why we see perceptual illusions, and it concerns the fact that when light hits your eye, you don't generate a perception instantaneously. That's what you'd like. You'd like it to be that just boom, you see exactly what the world was like when light hit your retina, right? But that can't happen. It takes about 1/10 of a second, it turns out, for you to create your perception, for your brain to do all the computations, and for all the sequence of neurons to get to the point where your perceptions are done. Well, a lot has happened in 1/10 of a second. Even if you're moving relatively slowly, you move a considerable amount in 1/10 of a second. If people are throwing balls to you, it moves considerably far in 1/10 of a second. You can't be the acrobatic ape that you are, and animals can't be the acrobatic animals that they are, if they are always 1/10 of a second behind in the world. So instead, it turns out that there's lots of converging evidence that we have ways of correcting for that delay, for that 1/10 of a second delay. Instead of generating a perception of what the world was like when the light hit your eye, the brain says, you know what I'm going to do? I'm going to try to anticipate what the world is going to look like in 1/10 of a second. Because that way, by the time I've created my perception, that perception, which is up to I'm building it of the future, but by the time I've built that perception of the future will have arrived, and I'll have a perception of the present. So I call this perceiving the present. And there's a variety of folks that have worked on a variety of things in here, but what brought me into that field is I realized that once you realize that animals have to constantly engage in these latency correcting for that delay, then there's lots of other consequences that people hadn't realized, including all of the perceptual illusions, including the geometrical illusions. So the geometrical illusions are the ones where you see two horizontal lines, and then there's all these radial lines going through it, and you perceive the two horizontal lines to bow outwards, for example. And so what I've argued in my research is that, in fact, in real life, when you see those kinds of radial lines coming up, well, they happen all the time in real life. Every time that you move forward on your retina, all of these things in your visual field are flowing outwards. They're flowing outwards in your visual field. They're radially moving outwards on your retina. When you end up with optic blur that's radially going outwards, like in those illusions, it's because you're moving forward towards the middle. That's what it means. That's the ecological or the natural situation. Every day, every moment of the day that you're moving forward, you get stimuli like this. And these are exaggerations. These radial displays are exaggerations of that. And so when your brain sees them, it says, oh, I must be doing a saccade and fixating on a point and then moving in the direction of the center. That's what it says. And so what your brain wants to do then is not generate a perception of those two vertical lines. In the cases of the Hering illusion, it's called the Hering illusion. It doesn't want to generate two vertical lines. It wants to generate how those vertical lines will project in 1/10 of a second by the time the perception occurs. And how do two vertical lines project in the next moment? Well, we've talked about these in some earlier videos about the non-Euclidean geometry of the way the world projects. When you're very far from this doorway, both sides are vertical. But when you get up really close, well, you can't really see. It still looks vertical at eye level, but when you look up, well, look, it actually starts to recede and get closer to one another as it goes up, and the same as you go down. So the parts below the eye and above the eye don't grow in your visual field as much as the parts at eye level. That means that the next moment, the sides of that doorway are actually going to bow outward at eye level and less relative to the tops and bottoms. the illusions that you perceive and all of these geometrical illusions are explained, I argued in these papers, almost 20 years now ago, are explained by the brain interpreting those kinds of optic flow, other kinds of cues in the stimulus. It says where I'm moving and says, okay, I'm going to generate a perception of the way those things will project toward my eye in the next moment. And that's why we perceive these illusions, because our brains are constantly trying to extrapolate the next moment so that we are in time with reality rather than behind. Right? Now, it turned out that class of illusions, which are called geometrical illusions, was just one of a huge class of illusions. I was able to show that same idea explains many other classes, and I don't want to get into all of those different classes today, but the basic idea is that when you move forward in the world, you don't just get optic flow that's radially moving outwards. You end up with lots of other kinds of cues concerning contrast, concerning the relative sizes of things, there's lots of kinds of things that you can work out mathematically about what predicts where I'm moving. And once you understand what predicts where you're moving in the next moment, then your brain can say, okay, I'm probably moving over there. And given that, I can modulate the stimuli, I can modulate the way things hit my eye and make them what they're going to look like in the next moment. And it turns out that the classical geometric illusions was just one of 28 different classes of illusions, of which there are many subclasses even within each of these categories. So it was sort of this grand unifying theory that pulls together and explains under one umbrella the geometrical illusions as well as all of these other ones. So you can watch the TED Talk that I had given 10-ish years ago. There's a couple other TED Talks if you're on it. One about why we have pruny fingers, another on why we evolved color vision, and our company Vino Optics, which has color blindness and vein finding technology, and FreeX Sunwear. You can find another TED Talk on that, which I'll put a little things on here so you can see and go find for yourself by searching on them. And again, get yourself a copy of Expressly Human. We are pariahs. I was not on the side of the media. I was not on the side of the typical academic when COVID happened. I was not hysterical. I argued for freedom and for free expression and against the lockdowns, against masks, because they were all irrational. That puts me on the outs, and I won't get covered by normal media, and I need your help. We need your help to get our message and our research out. And that was your science moment.